Hi guys, I am Joseph, a researcher at the Advanced Manufacturing Center or AMCen. Have you ever wondered how we can make our designs lighter, better, and stronger? I will show you how the various software and additive manufacturing solutions can help you optimize and realize your products. Optimized designs are very complex. They usually resemble organic structures that we normally see in nature. This makes the manufacturability of these designs very difficult, if not impossible, using conventional manufacturing processes. Conventional manufacturing processes like subtractive manufacturing, where we cut a workpiece to remove excess materials, or formative manufacturing, where we use a tool, usually a mold or a pattern, to create the needed form required by the design, has been the primary method of manufacturing. But these processes are not designed to manufacturing optimized products. They are limited by the orientation of the cutting axis or how the products will be released from the mold or even the volume production. However, through 3D printing, these limitations are overcome by printing any product layer by layer. This allows very complex geometries to be fabricated. With this technology, we can create better, lighter, and stronger designs with more design freedom. So let's take a look at how topology optimization software can harness the full potential of 3D printing. At AMCen, we start with the preparation of the model. Here, we use various 3D modeling software like SolidWorks, NX, to create a 3D model based on the concept design or design intent. This will be followed by topology optimization. For this, we can use specific software like MEC Apex to optimize our model by removing unnecessary materials from the target body while retaining its structural integrity. We would also need to define the loads, the boundary conditions, and then the software will do the optimization for you. Next thing we do after the optimization is print preparation and print simulation. This virtually simulates the entire printing operation. We can visualize how our product will be printed with reference to the build plate. We can also iterate the support structures that we need based on the geometry of the part, and depending on the type of printing process we are using, we can also incorporate the post processes we would need to cure or sinter our part. For this, we use several software depending on the material we are printing with. For metals, we use MEC Simafact, and for polymers, we use MEC Digimat. There are times that we might need to do multiple iterations on the print preparation based on the result of the printing simulation before we can come up with the optimized design printing parameters for our build. When everything is okay, we can finally do the slicing. Here, we cut the optimized model into very thin layers that will in turn be printed one on top of the other using a 3D printer. Usually, each 3D printer will have its own slicing software compatible with it. This software allows us to set up the appropriate printing parameters depending on the printing process we are using for the design, like layer thickness, print density, print patterns, among others, and then we print. Finally, we can produce topology-optimized industrial parts that are normally impossible to fabricate with lattice structures that are stronger and lighter, or aesthetically pleasing architectural designs that will leave us in awe, or furnitures that is so unique you can put your name on it. The possibilities are endless, and with the correct simulation solutions, we can ensure that we do it right the first time effectively reducing, if not eliminating, failed prints and speeding up your process even more. AMCen has all the solutions and technical expertise to help you realize your ideas, making the impossible possible through topology optimization and 3D printing. Again, I am Joseph, and together, let's go beyond the conventional.